Hello and welcome to this Python tutorial. So in the previous tutorial we imported the dataset and most importantly we built this whole list of transactions containing all the different transactions of the different customers in the store, and this whole list is actually right here. It's this transactions list of 7,501 lists, each list containing the different products of the different transactions. So if we open it again, that's the whole list. So as you can see, this list contains 7,501 lists. All the lists are here and each list corresponds to one transaction. So for example, this list corresponds to one transaction where some turkey and avocado were put in the basket and purchased by the customer. Okay, so that's all good, and we needed to build this whole list transactions variable structured this way simply because that's what the apriori function that we're about to use is expecting as input. So now we're all good and we are ready to train the a priori model on our dataset. So let's do it. The first thing that we're going to do is actually import the a priori function. So as a reminder, our working directory folder contains this apriori.py file that contains some classes and functions, and we're actually going to import the a priori function from this Python file instead of importing some classes or functions from an open source library like we used to do. Here we are going to directly import the function from this apriori.py Python file. So let's do it. It's actually the same syntax as usual. We're going to do from apriori import, and that's where we import the apriori function itself, and that is called apriori. And now we can take and use the function. So let's do it. We're actually going to directly declare a variable called rules, because that will be the output in some way of the a priori function. The a priori function takes the transactions as input and will give us the rules as output. Okay, so rules equals, that's where we use the function a priori and parenthesis. And now in this a priori function we need to input the arguments. So let's have a look at what these arguments are. So to do this we are going to do what we used to do, that is press Command I here to get some info about the a priori function, and here it is. So a priori function takes one main argument, which is the transactions. So that's exactly what we built here, by building this whole list of 7,500 lists, each list corresponding to one transaction. So that's the main argument, and so let's input it right now. So as the first argument, we input transactions. So for example, if you input dataset here containing the transactions in a data frame, that wouldn't work properly. You wouldn't get the rules as how we are about to get them. So that's why it's very important to build the transactions dataset this way so that everything works well. Okay, and now we have some keyword arguments, which are very important arguments when you use the a priori model for your business problem, because these arguments will actually depend on your business problem. It will depend on your dataset, the number of observations you have in your dataset, because of course your minimum support is not going to be the same whether you have 1,000 transactions or 100,000 transactions, and same for the confidence and the lift. So let's see what we have. We have a minimum support. That's the essence of the a priori model. We have to set a minimum support. Then we have a minimum confidence, also part of the a priori model when we need to set minimum confidence. And then we have a minimum lift. So that's a very important argument because the lift is one of the best criterion of the strength and the relevance of a rule. And then we have this max length argument here that allows us to set the maximum number of items we want to have in our rules. And actually there is also another argument, but that is not specified here. which is the min length. And of course, this min length argument allows us to set the minimum number of products we want to have in our rules. So we're actually going to use it because we want to make some associations between at least two different products. Okay, so let's input these several arguments. So first one is minimum support, min underscore support. All right, we'll explain very soon what value we want to input for this argument. And then we have minimum confidence, min confidence. Same, we'll see what value we want to input for this. We will explain that in a few minutes. And then what do we have? We have min lift. All right, the minimum lift. And then we also have min length. And that, as just mentioned, we already know that we want a minimum number of 2 products in the baskets, in the transactions. So we will directly set it to 2. And that is in order to prevent to have some rules of only one item, which actually doesn't make much sense. So great, and now we need to decide for a value of the minimum support, the minimum confidence, and the minimum lift. All right, so let's start with the support. The support of a set of items I is equal to the number of transactions containing this set of items I divided by the total number of transactions. And this support argument that we're inputting here is actually the minimum support you want to have in your rules. That means that the items that are going to appear in your rules will have a higher support than this minimum support here. So what we must ask ourselves is that what supports do we want to have of our different items in the rules so that the rules are relevant? And so now how to choose this support? Well, we need to look at the products that are purchased rather frequently, like at least 3 or 4 times a day. Again, that depends on your business goal, but what's for sure is that if we manage to find some strong rules about items that are bought at least 3 or 4 times a day, then by associating them and placing them together, customers will be more likely to put them in their basket, and therefore more of these products will be purchased, and therefore the sales will increase. So that will be the starting point of how we're going to set the minimum support. We're going to consider the product that are purchased at least 3 or 4 times a day. And then we will look at the rules, and of course if we're not convinced by the rules, we will change this value of the support. That's how we work with the a priori model. We try different values of the support, different values of the confidence, until we are satisfied with the rules and until we think it makes sense. And we can also try these rules within a certain period of time, and then we look at the impact on the revenue. And if we don't observe a meaningful increase in the sales revenue, we can later change the support and the confidence to change the rules, and then experience again until we find the strongest rules that optimize the sales. So that's actually what happened in real life, but of course in these tutorials we're going to try with products purchased 3 or 4 times a day, and so we'll see what happens. Okay, so actually we didn't set the support yet, we just decided that we will look at the products that are purchased at least 3 or 4 times a day, but that will quickly lead us to the support, because if a product is bought, let's say 3 times a day, that means it's purchased 3 times 7 equals 21 times a week. And since the support is the number of transactions containing this product over the total number of transactions, and since there are 7,500 transactions, then we get the minimum support that is equal to 7 times 3 over 7,500. So let me re-explain that by writing this here. So, okay, we said we considered the products that are purchased 3 times a day, so that's 3 here. Then since the total number of transactions were registered over a week, that means that if we consider the products that are purchased 3 times a day, that means they're purchased on average 3 times 7 times a week. So this 3 times 7 equals 21 here is the number of transactions containing this product bought 3 times a day over the whole week. And now we need to divide by the total number of transactions to get this minimum support. And the total number of transactions is actually 7,500. And this value here that we're about to compute is nothing else than the support of a product that is purchased 3 times a day. And we want our rules to consider only the products that are at least purchased 3 times a day. So all the products of our rules will have a higher support than this support here that we're about to compute. So let's compute it, let's find out what it is, and that's the value we'll give to this support parameter here. So right now I just need to press enter, and that's the value, 0.0028. We will round this to 0.003, and so that is the minimum support of the product that will be considered by our rules. All right, so let's input here minimum support, min support equals 0.003, and that will be the minimum value of our support, which seems appropriate for our business problem. All right, so done for the support. Now let's move on to the minimum confidence. So in R, if you followed the R tutorials, the a priori model is implemented in a package called arules, and this package contains some default value for the confidence. So what we did is we started with the default value, 0.8, but then we realized that we got too obvious rules because the confidence was too high. A confidence of 0.8 means that the rules has to be correct in 80% of the time, that is in 80% of the cases, 4 times out of 5. So of course you get some obvious rules, like you get some rules containing some products that are most purchased overall, and so they are purchased together not because they're well associated, but simply because each of the products is one of the most purchased products. So they end up in the same basket not for the right reason, not because they associate well together, but because they're purchased all the time. So I'll give you an example. This store is in the south of France, and maybe this transactions were registered during the summer, and since it's very hot in the south of France in the summer, people buy a lot of mineral water. That's actually the most purchased product in the store, mineral water. But then French people buy a lot of eggs too, because French people love omelets very much. And because they buy a lot of mineral water and a lot of eggs, a lot of the baskets of the different customers will contain both mineral water and eggs because they buy these products a lot. But it's not because they buy some water that they will need some eggs, or it's not because they buy some eggs that they will need some water. There is no logical association between these two products, and that's why it's not very relevant. And unfortunately, that's what we'll get if we set a confidence too high. So 0.8 is a too high confidence, and besides, we noticed that with a 0.8 confidence, we actually didn't get any rule because there was no rule being correct 80% of the time. So what we did afterwards is that we divided this default confidence of 80% by 2, so we got 40%, and that's where we realized that we got two obvious rules, like the rule I just gave you as an example, with the mineral water and the eggs, or other rules of the same kind. So then we divided again the confidence by 2 to obtain a 0.2 confidence, 20%. And considering the 7,500 transactions of our dataset and our business problem and business goal, well, we ended up with the conclusion that this was the right choice of the minimum confidence. A minimum confidence of 0.2, 20%, associated to a minimum support of 0.03 is actually a good combination and gave us relevant rules. So we will choose the same value for the minimum confidence here. That is, we're going to input 20%, 0.2. All right, so that's a good combination of choices of the minimum support and the minimum confidence. Okay, so now we have a last value to input. It's for the min-lift argument. So same here, we can try different values of the minimum lift, but what we would like to have is some rules that have a lift at least higher than 3. If we get some rules that have lifts above 3, well, these are actually some good rules, because the lift is a great insight of the relevance and the strength of a rule. And we're hoping to find some rules having a lift equals to 4, 5, or even 6. So let's set this minimum lift to 3 so that we get, some relevant rules. Let's hope we'll get some interesting rules with these combination of arguments. This looks actually fine. And remember, this depends on your business problem, on the number of observations in your data set, that is the number of your transactions. So you must spend a little time on this choice of the arguments here. Okay, so we are actually ready to train the a priori model on our dataset. So let's do it. We simply need to select all this code section here and press Command or Control plus Enter to execute. And here we go. A priori model trained correctly. All right, so great. And that's actually the end of this tutorial, because what we're going to do in this tutorials is the exciting step. That is, we're going to visualize the results. That is, clearly see what the rules are. So we're going to have some explicit rules telling us that if some customers buy this product, well, they will also buy this product with a certain % chance given by the confidence. All right, so I look forward to having a look at these rules, and until